I'm Chanak Sirimahanna. I come from a telecom background and I currently work at Nzinga. So Nzinga is an system integrator. So we basically do many kind of system integration, telco, fintech side, so banking sector, as well as the cloud side. So I'm specialized in the telecom side. And so we are a Sri Lankan company, but we have offices in Singapore, New Zealand, and Sri Lanka as well. So, and we have business in Maldives and Fiji Islands and those kind of areas as well. So back to the topic. I think the slide is shared, right? So
yes,
okay.
it is shared. Yeah.
Today that I'm delivering this lecture on wireless mobile communication. In today's content, I'll be covering some industry overview, especially how Sri Lanka is performing on the mobile industry right now. And then I'll give you some brief overview of what 2G, 3G, and 4G networks are. And then I'll discuss on what is a cellular IoT network. So I think it's a new thing that you guys need to know some basics of what is cellular IoT networks. And the next part is the 5G network. So I'll discuss what the 5G networks and how it impact to our lives and what are the new applications comes up with the 5G network. And the lastly, or not lastly, but then I discuss the key technologies for the coming of new technologies for this field on the telco. And later I'll discuss what the 6Gs look like and what we are going to do with the 6G. Yes. If you consider the Sri Lankan market on the telco side, especially the mobile communication industry, so what we can see is that we had a good growth so far, but currently we are saturated. So our subscriber connections are now not, so we are selling SIM cards, but the unique subscriber are not growing. And the market penetration is like almost 150, above 150%. And revenue wise also, now the mobile operators are saturated. So we don't see much revenue growth in the telco sector in Sri Lanka. In with more numbers, what we can see in Sri Lanka is that our mobile connection, so ARPU is average revenue per user. So our average revenue per user is somewhere around $2.41 per user, unique subscriber. So you can see over the last 5 years that has been dropped. The other things, 2G connections. So in 2018, we had 10 million 2G connections. Currently, it is only 2.7 million. The 3G connections also drop in, and some network operators has already shut down 3G network. And 4G connections are growing. So we have like in the last 5 years, 20 million new 4G connections have been added. So overall, what's happening in this legacy network? So I mean, legacy means the older networks, 2G, 3G, and 4G. So 3G network is shutting down in the most cases. So soon we will not have a 3G network, but 2G will continue for some years, and the 4G and the 5G will come in the future. So those will be the future connectivity options we'll have in Sri Lanka. So smartphone connections also, we have a high number of smartphones like as at now 2023. So basic phones connections are being reduced from 10 million in 2018 to now 4.7 million. So when this number is dropped significantly and there are more 4G supported devices, then operators can easily shut down those legacy networks. So that's how it goes. And the SIMs per unique subscriber. So that means that more than one SIM is used by the subscribers. So it's like 2.5 SIMs per subscriber in Sri Lanka. Yes, and now I'm moving on to this mobile technology evaluation part. So in general, for each 10-year, each decade, we have a generation. So 1980s, we had first 1G network. So 1G is a analog system. So this AMS based technology. So it developed for voice communication. And if you are young, so you may have not experienced this 1G technology. It was there in Sri Lanka, but in very limited areas. But what you have experienced from 2G to 5G. So 2G is basically a digital version of 1G, and there are some improvements. So being digital, that 2G is still a dominant player in many countries. So it's more than 30 years now, the technology. And so it initially developed for voice, but now we have some capabilities of the data access as well. And then 2000 onwards, we had 3G. So 3G is first to introduce mobile broadband. So that actually changes many things in countries like Sri Lanka. So some developed countries already had fixed line connections for the broadband, but in the Sri Lanka with the 3G, so many people started using the internet and access internet-based services. So this is a revolutionary introduction in 3G to Sri Lanka. So with 3G, so we have smartphones, and those apps related transactions started with the 3G from 2000 onwards. Then 2010 onwards, we are having 4G. So 4G is mobile broadband, so that is enhanced mobile broadband. So we have much more capabilities than what 3G offered. So we could be able to go beyond 100 Mbps. And from 4G onwards, the basic requirement of the mobile phone was removed. So that means the voice. So in the 4G, that the voice is not a key component. So voice is there, that we call is VoLTE. So that is something like application run on the data network. So it is not a dedicated voice connectivity on 4G, but VoLTE gives you the service like WhatsApp kind of thing, but it's in the with high key voice or high quality of service. So that's what the 4G comes from. Then the voice isn't now not that much necessity. From 5G that came after 2020. So 5G, what did this 5G introduce new applications? So one is like, so enhanced mobile broadbands, you already know that. So 4G it's 100 Mbps, then 5G will be more than 1 gigabit per second. So that's we already know that apart from that use case, we have another two use cases comes up with 5G. One thing is the massive machine type communication. So that means you may have heard that IoT kind of communication or M2M communication. So that means we try to connect everything. So in the 5G era, we call it connected everything. So we connected humans, connected things, and anything that has some information on it, we connect to the network and we get that information to our part. So that is the requirement on this massive machine type communication. And the other requirement is ultra reliable low latency communication. So this is very critical component. So this is a very new component. This ultra reliable low latency that gives you ability to applications like autonomous driving. So as name suggests, so this is very ultra reliable. So the autonomous driving, so networks has to be very reliable. So there cannot be any packet drops, and there cannot be any failures or anything. So, and also latency. So we cannot delay certain message for sometimes, because the message has to be uh, immediately transferred to the other end. So for that, this is a very we can call this expensive network, because the network quality is very high. So that's why this is very, we call it critical communication. So critical kind of communication, we use this kind of network. But for the general use for 5G, we have mobile broadband, and IoT kind of application, we have massive machine type communication. I'll discuss all those in the later slides in detail. So from in this trend, so you can see there's something here has to be 2030 plus. So that is a coming up technology that we call 6G. So in the 6G, we call it connected intelligence. So in the 5G, we call it as a connection of everything, or everything connected to each other. But now it's connected intelligence. So I'll discuss that in my final part of the lecture, what is connected intelligence means. In the basically, when you analyze cellular concept, so we generally call the mobile network a cellular phone or something. We used to call that name. So what is the cellular concept in a mobile communication? So that it's the basics that we need to understand. In cellular communication, what we do is we take the geographical area and divide it into cells. So this we can call cells. So these are the cells, right? So in so what we do, so in in these corners of the cell, so we establish our base station or our tower. So the tower basically has three antennas to three directions, right? So in these, each antenna will serve this cell. So somewhere here, so we'll have another tower, and we have another three antennas in these three directions. So from this antenna, let's say for this antenna, so it is served by this area. From this antenna, it is served by this area. So what is so why we need to this kind of demarcation of the geographical area? So why we can't use one single tower to cover up the entire Sri Lanka? For example, if you see the broadcasting technology like TV broadcasting, so they use only one tower. For example, they have Pidrutalagala, so it can cover like almost 50% of population, right? So they don't do one-to-one communication, or they do broadcasting, right? So, but in our communication method, so we have to send a customized message or their own payload. So different payloads for different users. So in that case, if you only have one tower, that tower should have very high capacity. So what we have done here, so we have divided area into small cell, so that particular resource, so let's say we are assigning in the wireless communication for a radio, we call it radio channel. So that channel we share, or we use that channel to communicate. So let's say we have that channel called channel that using frequency F1, right? So that frequency F1 is here. So then same frequency, so we can reuse somewhere else that there's no impact from that F1. So likewise, we can share the resources. So whatever used here, we can reuse somewhere else, right? If we use only one tower, we have to share all this F1 to all the users. But now only the users in this area will share that F1 resources. The another place users also share the same F1 resources. So likewise, we uh, 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 efficiently manage the available resources using the cellular concept. So this is why we call the cellular phones and cellular communication. So this is applicable for all Gs, that means 1G to let's say for 5, 6G also the same concept is there. If you have any questions, please ask, right? So I don't know whether you understand or not. So if you have any questions, please interrupt me and ask your question. Let's start from the GSM side. So So GSM is the second generation telephone network or mobile network. So what GSM is doing, so GSM is assigning you a channel. So as I said, in the wireless communication, we give particular channel. So each channel has a channel bandwidth. So bandwidth is the how wide your channel is. That means, let's say if you have a road, so is it a 1 lane road or 4 lane road? That is the bandwidth. So in the 2G network, so it's a very narrow band. So the channel is 200 kilohertz is the channel band. So that means, let's say it's a one lane road, something like that. So we are assigning such a narrow band to a particular user. But so if we are assigning 200 kilohertz channel for particular user, so there are many users, like millions of users. So how we do it? Like for example, in the cellular concept also, if you take a village or something that covers a one cell, so there are also multiple people assigning need to channel make a calls. So what we do is, even these 200 channels, we have a limited number of channels. For example, one operator may be having 20 of those channels, right? So if we allocate 20 to a particular cell, then only 20 concurrent calls can take from that particular cell. But in generally, there are more capacity. So how we do that is, we assign only particular time slot for particular user. So that technology we call is TDMA. Like in the TDMA, so let's say you assign the channel for particular time period, then it switch to another user. Again, after some time, you take a chance to communicate. So this is the
These theorists have done for them actually. You can
okay,
just
okay,
switch.
okay.
Yeah.
Okay, I can skip. Okay, so that is the TDMA concept. And the other major factor here in the 2G is that we use hard handover. So handover is the one major concern when we compare it with the mobile network, because uh, so let's say you are traveling from Kandy to Colombo, Colombo to Kandy. During that period, so we'll have past 100 of cells, right? So if you are in the call, so you have to your call has to be hand over from each one cell to other cell, but you will never notice. But if there's something wrong, your call will be dropped. So handover is a very critical component in the mobile network. So in the 2G, so we had hard handovers. That means, so once the other connection is disconnected, and then after you connect to the next connection, so there is no backup for, if something goes wrong, the call is dropped. So in the later versions, we have soft handovers where you connect the both, and then you smoothly hand over to the other one. So that in the 2G side, your phone only connect to the one base station or one cell at the same one time. So that's why the hard handover. So data speed is low, and this is developed mainly for the voice. Then the the main critical factor that we have to highlight is this is still used. So why this is still used, that is we have to understand and think why we are still using the 2G. The main things that in my opinion, so why 2G is this much popular, that it is even developed in like 30 years ago. It's very much optimized for its purpose. So even after now, I mean 30 years ago, if you are doing the same service, so we will be mainly using the same kind of resource, like a 200 kilohertz channel band. So that is the reason that 2G is still there. And let's say even the 4G is there, but as I said, 4G does not have built-in voice capability. So if your phone or if your device does not support VoLTE, so then what happened? Your phone switch over to 2G and then make the call, and then goes back to 4G. So therefore, this 4G network will be there for some time. Let's say for another 5-6 years or at least, the 4G network will be there. Sorry, 2G network will be there. Uh, Next time talking the 3G. So if you have, I don't know whether you covered or not in the 3G as well. So 2G we use TDMA concept as I discussed, and in the 3G we use CDMA concept. It is a code division multiple access. Here what we are doing, when we compare with the 2G, we assigned one channel a 200 kilohertz channel. So now it's a much larger channel, very larger compared to the 2G. It's 5 megahertz, right? It is 5 megahertz channel. It's almost like 25 times more what we had in 2G. And this channel is very wider, but the thing is that you are not the only one using that channel. So now everyone in that particular cell using the 5 megahertz, but you have your own spreading sequence. So your whatever the information you multiply with that spreading sequence, then your signal will be spread among those 5 megahertz channel, right? So others will also have their own signals, and everything we come together and transmit. So when you receive the signal, what you have to do is you had it again, multiply your signal with your own spreading sequence, then you can recover your information. So others will multiply with their spreading sequence and they will get their signal. Likewise, this is a kind of sharing the same channel bandwidth with multiple users.
So this can be explained in mathematically only, you know.
Yes, yes. So yeah, so these are the mathematical explanation are much easier, but it's difficult to understand in short time. So it's very long process. So the other thing that in this spectrum principle is that this is what your signal. Once it's spread over very large bandwidth, very large channel. Then power distributed among that channel. So when you transmit your signal, there's always an interference or noise. So we call it white noise. That noise comes in only certain frequencies only. So not all the frequencies are having noise. So let's say this is the original one you transmitted and there's something new signals added in between. So this is what finally you receive. And then in the despreading situation, when you despread your signal, what you're having here is that your signal will be filtered out and the noise will be spread out. So this is a very good thing when you compare with it, when you compare with this noise reductions as well. So it's better handling noise as well. So that's why the 3G could deliver some high data rate compared with the 2G. So in the summary, UMTS use 5 megahertz bandwidth, and WCDMA is the multiple access method. So the technology is CDMA. We use the term WCDMA, means the wideband code division multiple access. So it's very wide channel is used, 5 megahertz. So that is a very wide on that time. So it's a very new technology. So when they first come up with this concept, wideband code division multiple access. So here that handover, both hard and soft handover is there. So let's say in the soft handover, it connects to two cells or two base stations at the same time, and you can smoothly hand over. So the possibility of call drops are lower in 3G, and the data rate of 3G we could go somewhere around, I think, 24 Mbps or something. And there also, if you the maximum, I think you could go like 42 Mbps or something. It's the maximum data rate that user can go with 3G.
This UMTS stand for
Universal Mobile Terrestrial. That I cannot remember. Yeah.
Yeah, that is the 3G actually. It is 3G standard. No?
Yeah, this is 3G
European
standard.
standard.
Yeah. Yes, those all standards are coming from organization called 3GPP, third generation partnership projects. So 2G, from 2G to 3G, now 4G, 5G, and mostly 6G will be standardized by them. But the original owner of these specifications are ITU, International Telecommunication Union. So they publish how 3G networks should look like, and how 4G should look like, and how 5G should look like.
Concept.
And concept. Yeah, and then the organizations like 3GPP or let's say IEEE, and there are organizations like Y, so they
There
can
is a
submit their
telecommunication union.
yes, and they can submit their proposals to ITU. So this is what our 5G is, this is what our 6G is, but whatever the globally accepted so far is the 3GPP. So IEEE also having 4G concept, 4G network, but it is not globally accepted. But the 3GPP specifications are the globally accepted. So that those 2G specifications, 3G, 4G, 5G, all comes from this 3GPP organization. So they each year they release their specification updates. For example, the initial 4G is not is updated several times. Even now also we'll have several updates. So for the 4G network, so time to time, so they make things, they changes the network. So the 3GPP is the one that comes with these specifications. And spectrum point of view, so in Sri Lanka, so this is the what published by the Telecommunication Regulatory Commission in Sri Lanka. So in mainly the mobile communication, we have three bands. One is the 900 megahertz, 1800 megahertz, and the last one is 2100 megahertz. These are the three bands used in Sri Lanka. And so 900 megahertz is the initially deployed band, the very first stage. So what the most important factor here,
This
that
information is available in the Telecom Regulatory Commission website, no?
website, exactly. So I,
Publicly
yeah,
available it is.
publicly available. And the most important thing here is that when the frequency is higher, so you have more bandwidth, so that means channel is wider. So now for example, the 900 bands, old operators are like 7.5 megahertz kind of bandwidth. So let's say for Hutchison, so they can have 1 5 megahertz band for the 3G and a rest of for 2G or something like that. So they can deploy the way they want. And in the 1800 megahertz band also, different operators are allocated different channel bandwidth. And so recently also that we see that Airtel and Dialog they merge together, so that, so let's say in such a scenario, then they have very large channel together here when they are in adjacent, so now easier to deploy network. So these kind of strategies they are using. And this 21 megahertz allocation here also, we can see different operators are allocated different bandwidths, and the operators has to pay for each megahertz they are using to TRCL. So this is a very expensive resource, this frequency allocation. So each operator paying very large amount of money to government to keep this spectrum in their ownership. Now I'm coming to the 4G. So in the 4G is the one that currently widely used in the world. So 4G peak data rate initially target 100 Mbps and uplink 50 Mbps, but currently like we can go even up to 1 gigabit per second in 4G. So it's based on how you configure the network and what are the specifications you are using. So initial 3GPP release, this is the speed, but now after like 10 15 years, now this in the specifications are older, so now we have go up to 1 gigabit per second. But for that we need to have resources. The main resource is the spectrum. So if you have more spectrum in this region, so for you, so then you can go very high speed even in 4G. So the 4G, the one thing is we have to highlight here, the 4G channel bandwidth are scalable. For 2G, we see 200 kilohertz the channel bandwidth assigned for a particular user. 3G, it's 5 megahertz. For 4G, so we have multiple options. Operator can have either 1.4 megahertz, 3.3 megahertz, 5 megahertz, 10, 15, 20. So 5 is the 3G one. So even operator can go lower channel bands than 3G. So in that case, the data rates may be lower than 3G. And in higher channel bandwidth, so we can go higher data rates. So with that, operator can effectively use available spectrum. For example, like you have 7.5, so you can use either 5 megahertz or another 3 megahertz carrier or something like that. Operators are more flexible with this. Multiple options are given by the specifications. So apart from that, those are the main highlights. So on the 4G, and this is the how that multiple access or sharing that spectrum with multiple users. So 2G we use TDMA, so each user assign the different time slot. 3G we use WCDMA, so each user assigned a different code. And now in the LTE, what we are doing is we are going back to the very old age, that is FDMA. In the FDMA, what we are doing is we assign a frequency for each user. Each individual user, you have your own frequency, right? So in that case, if there are multiple thousands of users, we should have thousands of frequency. That's a different story. But the problem here is that we cannot just assign a frequency like this, right? So when we develop, when we generate a signal, so you will have multiple iterations of that signal that goes into the infinity. So that is actually can prove the mathematically, but let's assume. So we cannot just generate signals in this way. So what we are doing is we keep guard band, or we when we do such an implementation, we need some guard band to avoid that iteration. So because we cannot just have signal like this, so there can be lobes of side lobes or many side lobes around this. So what we are doing to avoid or to reduce that impact, we keep guard band and we assign another frequency channel. So this one for user 1 and this one for user 2. So has a guard band also. Therefore, this is very inefficient system. So we need very large spectrum if you are doing this kind of implementation. But in the 4G, what we do is we find frequencies orthogonal to each other. So in physics or in mathematics, you know, two vectors are orthogonal, they each other, then there's no impact on each other from that orthogonal vectors. Similar here, concept is similar, that we use frequencies orthogonal to each other. So then we can overlap on each frequency. So likewise, we can pack them together. Even though they are overlapping, they are not impacting or they are not interference to other, because they are orthogonal. So this is the concept we use in 4G, the technology that we are described here as orthogonal frequency division multiplex. So each user will have different frequency, but they are orthogonal frequencies. And so we save the band. So that is the concept that we are using in the 4G. So this is a new concept from TDMA to CDMA, and now we call FDMA. OFDM, orthogonal frequency division multiple access. So this is the technology used in the downlink. So they mean for the base station to your phone, in the base station they are doing this. What your phone to base station, we are not doing the same, because if you are doing this, so you need a lot of power and processing in the mobile. So in the uplink, so we use a technology called SCFDM, that is single carrier, same thing, but it's on single carrier. So that's why in the 4G you see that your downlink is sometimes higher, but uplink is limited to a certain frequency, certain maximum speed. So this is the basic concept of the 4G and how it shared with multiple people. And yes, so this is what I discussed earlier, that when you generate such a signal, there are multiple side lobes around that. So this goes to infinity in mathematical calculations. So here that we put them together, but there's no impact. So this is the beauty of orthogonality. So then after we have 4G plus. If your phone says 4G plus, it doesn't connect to the initial version of the 4G. It is a later release of 3GPP for the 4G. So in the 4G plus, we call it any carrier aggregation, right? So in 4G, as I told you, so we can have multiple options of carrier, like 3 megahertz channel bandwidth, 5 megahertz, 10 megahertz, 15 megahertz, 20 megahertz. 20 megahertz is the maximum channel bandwidth. So when the channel bandwidth is higher, your data rate is higher. And what carrier aggregation comes up with, so your phone can connect with multiple carriers. Let's say if the operator is having a 15 megahertz carrier in one frequency domain, one frequency band, and let's say in the 1800 megahertz band, the operator is having 15 megahertz carrier, and another frequency band, he has 5 megahertz carrier, right? So your mobile can communicate with both and give you a better data rate. So with the 4G plus, so you can have very high data rates. So as I told you that the maximum 5 carriers can communicate at a one time. So if that all carriers are 20 megahertz and totally 5 carriers, the 100 megahertz bandwidth, so you will go beyond 1 gigabit per second in 4G as well. So this is how 4G evolved as at now. Yeah. So my next topic is on cellular IoT. So I think that you are on background on the IT side, and you need more on the application perspective of, with regard to the telecom. So this IoT is something that very old concept, but still shaping up. So we are saying like 2030 or very young age, so everybody is thinking how we connect something to the internet and control. But the problem is, so that is not financially feasible. Like, so if you can do your own DIY project and have some way of connectivity, but when you are doing it in the millions or like in the industrial scale, so connecting each and every item into the internet and controlling that's very costly, right? So you have to pay the same cost as some person accessing the network, because these current networks are developed for human usage, so it doesn't develop for the this kind of IoT kind of application. So those applications may be not that much significant like human uh, requirements, and it doesn't worth paying that amount for that kind of connectivity. So for that, as a solution, so the mobile IoT is coming, so that is dedicated for the IoT communication. So this is one kind of in this slide, so what has almost some kind of a uh, use case, that this is for the uh, greenhouse farming. So in that case also, uh, like a soil moisture level, acidity level, temperature, and all these functions are sensed and transferred to the central server. And for that also, so what happens, so when uh, uh, let's say in that scenario, with this connection, IoT connectivity, so that we can see is there any problem in the crop before actually it shows with the harvest or anything. So uh, there are many uh, this kind of applications are in China. So China currently having 63% of global IoT connections are currently in China. So they have many kind of solutions, like from connecting your uh, everything, right? So like the electricity meter or uh, parking and street lights, household equipments, and everything that we can connect it to the internet and control. So the China is the leading, and so they are the leading manufacturer. So have the market demand and they have the supply. So they have everything in the IoT ecosystem. So that's why they are performing very well on this market segment. And if you're actually developer and trying to find so how I should connect my IoT application to the network. So there are you have two options. One is unlicensed spectrum or the licensed spectrum. So the unlicensed is like Wi-Fi and Bluetooth, so that you don't need to get permission of anyone to use it. But in the license is the operator pay to the TRC and they get the ownership. So in the unlicensed part, so you have multiple options like LoRa, Sigfox, and Zigbee, also Wi-Fi and Bluetooth also possible. But in the license, so we have traditional networks. So as I told you that these are not built in for IoT applications, and there are network that is especially built for the IoT applications. So in this scenario in the Sri Lanka, we have these two options available: LTE Cat-M and NB-IoT. I'll discuss that in the later slide. So why cellular is for the IoT is because if you deploy your own network, so you have to do it from the ground zero level, and cost and the effort is much higher than using from the existing existing mobile operators IoT network. Here in this graph, I have compared what this Cat-M1 IoT network and the NB-IoT network. So in the downlink rate of Cat-M1 IoT network is 1 Mbps. NB-IoT network is 170 kilobits. So this is much lower data rate, and uplink also much lower in the NB-IoT, and uplink on the Cat-M is 1 Mbps. The other factor here is that NB-IoT is half duplex. So that means you cannot send and receive at the same time. So you either send or either receive. And the other thing is the complexity. So if this is the Cat4 is a general 4G phone. So if that is 100% complex, the NB-IoT is 15% complex. So when the complexity is low, so you need less silicon chips and everything, and the the cost of the equipment is much lower. So these are the basic features that we can see on the NB-IoT network. And so other than that, NB-IoT designs to have much higher coverage, even in the basements and very difficult places to normal network to reach. But NB-IoT will have much better coverage, and it has much better battery life. So generally we call up to 10 years battery life is there, depend on the application. And some applications that you once you charge that product, then you don't need to charge that particular product again. And as the device complexity is low, this is very cheap, and the system bandwidth also low. So that means it doesn't need much bandwidth in that operator's expensive spectrum. So again, the cost is lower, and the capacity is higher. So that means, so even for example, for one particular cell, if you say for it can serve like 100 people, for this will be like served by the millions of devices. So that kind of very high capacity is there. So these are the deployment so far. So this is an update from the 2022. So there are 170 networks, and Sri Lanka is also in the map. So if you are developing some applications, so you can consider using NB-IoT networks. And also Cat-M is there, but Cat-M is for particular different kind of applications. You have much higher network quality only, so you should go to Cat-M. So it's a little bit expensive than NB-IoT. The other factor that I have to go with that is the 5G network. So in the 5G network, so mainly came up with supporting 4K and 8K videos and augmented reality kind of applications. And other factor is M2M communication related, as I said, IoT related communications. So in the first slide also discussed with on this 5G technology requirement. In the 5G, we have three requirements. One is the enhanced mobile broadband. So that will enhance whatever your data requirements or whatever your broadband requirements. So up to 20 gigabit per second, seconds from 1 gigabit per second. And the next one is the massive machine type communication. It is kind of the same kind of network that NB-IoT is used for. The last one is ultra reliable low latency communication. That's, as I said, it is for applications like autonomous driving. So here what you can see is a glimpse of applications that we can use for, let's say, massive machine type communication or IoT kind of communication.
These software developers, they have a lot of opportunities from these things.
Yes, exactly. So
therefore, those who are in the software development field, I think these things are very important. You can have your own entrepreneur and you can have the developments and you can sell to the whole world some application. Okay, Chami, go ahead.
yeah, so it's smart home, something that I think we already know that how our day-to-day appliances can connect to the internet. Other things, logistic handling. So as these devices are cheap and doesn't need to charge, so it doesn't consume much energy. So you can have a NB-IoT tag on whatever your package or something, and you can easily track that. The smart agriculture, again, I discussed how greenhouses and those things are managed with the IoT connectivity. So these are for massive machine type communication. And these three examples in the last three, especially for the critical communication, or what we call ultra reliable low latency communication. So in the ultra reliable kind of network, autonomous driving is there, that you need a very reliable and low latency communication. The other factor is industrial automation. So if you have heard the term industry 4.0, here what we are doing is each and every machine, each and every robot of that industrial production line is automated using connectivity. So in that case, each and every part has to be coordinated and work together and collectively give a much better output, much better efficiency on their production. So for that case also, we need very critical kind of communication. So latency and the reliability has to be there. So other things that apart from that, this telesurgery also very popular use case that we are talking in the industry. So what we can do with the 5G ultra reliable low latency communication. Here what we are doing, so let's say for a doctor who is in a surgeon in Colombo and the patient in some faraway place, let's say in the Jaffna or some faraway place, what he can do, there's a robot in the other end with the patient and the doctor giving instructions to the machine, right? So whatever the instruction is given by the doctor is immediately transferred to that robot with the patient, right? So then you can do the surgery, remote surgery. So this is a very popular use case, but these kind of use cases are discussed with the 5G. So yes, those use cases are there, but actually which drives 5G. So if you think in the actual scenario, so you can argue that we don't have autonomous driving cars in Sri Lanka or telesurgery. It's a very, it's very unlikely to happen, or maybe like 10 years ahead we'll have telesurgery. But what's the real reason that currently we need this in Sri Lanka or any other country is that uh, the traffic growth. So mobile traffic is basically doubled every 2 years or 2.5 years. So in that case, we need the more bandwidth, more network resources. So that is the main drive that the most mobile operators are deploying 5G at the moment. So some operators in the world hasn't got. I mean, they have fully saturated with the 4G, so they cannot go beyond 4G and serve their customers. So they need definitely some new technology for the upcoming data demand. So you can see this exponential growth on the 5G data demand, and we can see in the 2024 or something, this is the predicted how networks are evolving. So 5G will slowly come into the picture. So now it started from 2020 or something, but now slowly 5G is taking place, and even Sri Lanka we have 5G. So if you are living in Colombo, Gold, Kandy, some kind of a big city, so we have 5G deployed in Sri Lanka as well, but that is only for trial use. So we don't have commercial 5G yet. But still, if you are having a 5G capable device, you can experience 5G. So when as I said, the spectrum is the most critical factor. So if we have high bandwidth, so you can have high data rate. So that is simple as that. So in the 5G also the same principle is there. So you can use 5G with the existing spectrum, existing 4G, 2G, and those spectrums. So we can remove, let's say we can remove 3G and we can add 5G. So that is the one option. So that is, these frequencies are we normally now call low frequencies, right? Because with the 5G we are going for higher frequencies. So these low frequencies is the existing kind of our existing frequencies for 2G, 3G, and 4G. Or we can use some medium frequency, so some higher but not very high range of, or else we can go very much higher frequencies. So we call it high frequencies above 6 gigahertz. So we have never used this above 6 gigahertz frequencies for any other communication. I mean, for the consumer communication. So these were used for some specific kind of communication. So far we have used up to this. So from 6 gigahertz and below, because you know that Wi-Fi is using somewhere around 5.45 gigahertz band, and so these are the current level utilizing band. So we can go some new spectrum bands as well. So in the most of the countries in the world actually deploying, even the Sri Lanka, what we have seen is deployed in the 5G in this middle frequency band, right? So the channel bandwidth is basically 100 megahertz, right? For the 4G, it's the maximum 20 megahertz. So now 5 times higher than the 4G, and that is the one most popular in the world. And so data rates you can go up to, in practical scenario we have seen like 1.5 gigabit per second can be achieved. And if you're using the same frequencies like below 2 gigahertz, you will not get much difference. There is a significant, not significant, but small difference with the 4G, but not much gain in the data rates and everything if you use the same low frequency. So this is not used in most of the countries. So there, because there's not much difference for the 4G and doesn't solve the problem of needing higher capacity of the network. So this is the popular one. So this is also used in some countries, high frequencies. So like the examples are, let's say for a we are having a football match or cricket match, like 100,000 spectators are there, and in such a scenario, so we can deploy this high frequency super data layer. So here, like a data rate, so you can go up to 20 gigabit per second. But the problem here, when the frequency is higher, it doesn't go much distance, right? So let's say in this lower frequencies base stations, we can cover like 10 kilometers, 15 kilometers. But when we go to the medium frequencies, it may be 1 kilometer, 2 kilometer range. But when we go to the high frequency range, it will be few meters, few hundred meters, let's say 100 meters, 200 meters. That will be the maximum range. So that's what's the problem. When the frequency goes up, it cannot penetrate buildings and people and weather conditions, different scenarios. So in simple terms, the most popular one is the middle frequencies, and this is the 3GPP, their specifications. The N78 is the channel that most popular. So that is from 3.3 gigahertz to 3.8 gigahertz. And you can see, if you see the specification of 4G,
This
5G.
3GPP R5, the 3GPP have different releases, no? Release 5, release 6, like that.
Yes, this is from release 15 version, and the mainly used in this frequency in all over the world, and this is the deployment, and this N258 is that ultra high frequency. So this is mostly used in US, and those are there. Even device specifications, you can see this is iPhone 12 actually, and you can see that it support 5G N78. So this is the problem with very high frequencies, that this is a comparison with 850 megahertz and 76 gigahertz, right? So, and let's say, for example, when we go like a 10-kilometer radius, 10-kilometer distance, 10,000 times loss due to free space path loss. So even when the frequency is higher, here in the example, the signal power is 10,000 times lower when you are using very high frequency. So high frequencies are not always possible. And so there's a one solution for that is the beamforming, right? So in general antenna, what we are doing is that we are transmitting our signal in omnidirection, so that our signal goes to everywhere. So our signal power, let's say signal has 20 watt power, that power goes all over the places, and the user is here, user may not get that signal power. But in that in this situation, what we are doing is we create a beam. So we focus all the 20 watt power in one particular beam towards that user, right? So then we can have a much higher distance, much higher coverage of that particular set. So in this scenario, it's called beamforming. So we can increase our coverage that we lost due to that high frequency. So this is a technology that comes with 5G. And to do that, actually what we have to do is we should have multiple antennas. If you're using one antenna, it's like omnidirectional, right? Only one antenna, the signal is like that. So if you use antenna array, and we can focus our signal towards the particular user. So to do that also, we cannot do that in the lower frequencies, because antenna size is higher when the frequency is lower. So if you have know any idea of the antenna designing, so let's say for TV antenna, so VHF antenna is much larger than the UHF antenna, because when the frequency is lower, you need large antenna. So likewise, when the frequency is higher, so antenna size is small, because antenna size is depend on the wavelength. So there's the advantage. So and now antenna size is small as the frequency is higher. So we can pack many antennas in a small area, and we can have this directed beam towards particular user. So from that beam forming, we have another advantage coming up. That is, let's say for this user have one beam, another user in the same area or same cell has another beam, right? So it is like now, let's say the channel is 100 megahertz. This user has entire 100 megahertz. The another user has another entire 100 megahertz. So sharing is now limited. Or we can have more and more beam. So then our base station capacity or network capacity is higher. So this is another advantage of beamform. So we call this massive MIMO. In the massive MIMO, different users will have different beams. So this is the principle that 5G uses. So in the 4G also we have MIMO. So that is called multiple input and multiple output. But in the massive MIMO, this is much different and much advanced. In the normal MIMO, that if you have experience in the Wi-Fi also, MIMO is there, but it use multiple antennas and get multiple streams. But here we use multiple beams in 5G. So this is much advanced. And let's say if you have like previously for a cell one particular lobe, and now you have multiple lobes. So you can like multiply your network capacity by, let's say, 5 times, 10 times, based on number of how many number of beams that you can deploy in particular base station.
Normal MIMO also, we have one beam for one user. No?
Normal MIMO is what we are doing is we use the advantage of multipath propagation. That means that signal can come with different routes. So let's say we are not in the line of sight. One signal come with the reflection of one surface. Another signal may come directly to us. So we'll have two signals coming from the one base station. In that case, so we use two antennas and we identify those two signals separately, and we can send two data streams on that two separate paths. So then wise we can increase our data rate. So this is the general MIMO. So for that we use multipath propagation. If you are we get signal from different path, so we have we send a different signal on that different path. So now we have different beam towards it.
Okay, right. Thank you.
Okay. The other thing that I'm talking is that the future network deployments and key technologies, and the one big thing happening in the telco industry is that NFV and SDN. So I hope you guys know NFV and SDN. So NFV is the network function virtualization, and SDN is the software defined network. So in the NFV, what we are doing is that we remove the bond between hardware and software. So now most of the telco solutions or telco whatever that telco equipments, they don't ship the equipment. So that's only software. So entire telecommunication systems are now a software. It's just completely software based industry. So what we are doing is that we have a software vendor who's actually writing the code, writing the software based on what the 3GPP and what other organizations are defined. So under the specification, they write the code. And there's another vendors, let's say for a HP, Dell or something, the servers. So we use their hardware, and nowadays we mostly don't use that VMware or anything such a thing. So most of the deployments are bare metal. So it basically on Kubernetes and microservice based framework. So containerized frameworks. So those are the new developments comes with telco. So most of the telco vendors are nowadays are software vendors. They are software companies. So hardware is from the hardware companies, and so everything is in the history in the like that 5 years ago or 10 years ago, when we buy a telecom equipment, it comes with the hardware, and it's like very large servers that is built for that purpose. So we cannot use it for any other purpose. And the problem in such a scenario is that uh, aging, like, so the hardware is, there's a limited time for that particular hardware, and then after we have to completely remove that particular product and install new one. So it's a very it's a very uh, uh, kind of
Costly.
costly, and you don't have much options. So let's say you pay like 1 million USD and bring down some equipment, so you have to use it for like a 10 years or something until that you get the full benefit of that investment, right? But nowadays you don't need to do that. You pay the software vendor, let's say for a yearly basis you pay. So I need the software and I'll pay this much annually, and you buy hardware from the hardware vendor, and let's say the hardware is end of life, so you simply remove the hardware, but your software component is still there, and software is evolving day by day. So the software, I mean, this is a software audience, so they know how this continuous development and continuous integration process. So when the telcos follow in the process, so your telco systems are continually evolving and continually updating. So this is very open now for any vendor. So any software vendor come up with their solution that uh, suits with the 3GPP requirements, so they can enter the business. So now the telecom industry is open up for many multiple vendors, and thanks to this virtualization concept. So SDN is another concept that is for the networking side. So now initially, I think you guys know this one. So initially we had like uh, uh, distributed network control, but now we have central controller, and all network functionalities are controlled centrally. So those are the new things that already has come to the telco. And for the software industry, so they have many multiple opportunities and come up with new softwares for the telco field. So but I haven't seen Sri Lankan entrepreneurs are doing this. Many of the Indian small businesses are now enter the telco, so they have multiple solutions. So I ask you guys also can start some things in the telco industry, because these are very telecom is a very $1 billion industry. So if you have some good products, so it's very good business. So in the 5G, that the network slicing is there. So in the network slicing, what we are doing is, so let's say if you have a company, so that, and you want to have your own network within 5G network, you can have. For that, you can have your own core network, your own firewalls, or on everything. So you, whatever the under your regulations, you can put it in the mobile operators cloud or mobile operators core network in the virtualized platform, and you can run it as your own 5G network. So that's what the network slicing is there. So also, uh, let's say for a Sri Lanka a port authority, so they have their different use cases, and they want to automate their uh, uh, cargo handling and everything, and they don't even want internet, so they only want to connect to their servers. So if they want to use a 5G, what they can do is they can have their own core network with their own rule within operators network, and use 5G. So this is also possible because of that virtualization. So now we can have multiple instance of everything, right? So if you previous generations, we have, like, say one particular equipments that is there, but now that with this virtualization concept, you can have multiple instances running at the same time, for particular different users. So that is also a advantage of having this virtualization concept in telco. And another thing that's happening is the radio side. So in the telecommunication networks, uh, uh, there are basically two things. One is the RAN and the core network. So RAN is the where the base stations and towers are located, and the core network,
Radio access network. Radio
yes,
access network.
radio access network. So in the radio access network, you have the base station and radio side of that, wireless side, and the core network is where the intelligence is there. So there you got the charging, you got the access control, and every intelligence aspect on the network connection is handled by the core network side. So core network side is it's obvious that we can do the virtualize, uh, but in the radio side, even currently also, it's dominated by one or two major players like Huawei, Ericsson, ZTE, Nokia. Those are the suppliers of the radios. So if you see that globally, everywhere you can see those base stations are provided by those one or two vendors. So to avoid that also, the network operators joined together, and they started their own specifications and open up the interfaces. So what these current vendors are doing is their interfaces are, they are proprietary, so no one else can join. This is what the legacy ran, right? So radio access network. So in the base station we have antenna and the radio unit. So radio unit actually generate the radio signal and antenna transmitter. And there's a baseband unit. So this unit is basically located bottom of the tower. This is on the top of the tower. And then the core network is the one that I already discussed. So this is the legacy RAN. So all these parts are provided by, in the legacy RAN or existing RAN, one particular vendor. Let's say Huawei, ZTE, or Ericsson, Nokia, and there are a little bit of Samsung. That's all. But with the Open RAN, so what they do is that they also remove these proprietary interfaces, and they define globally accepted interfaces. So any vendor comes up with their following their open interfaces, then we can integrate to those systems. For example, now, so we can get antenna and radio unit from one vendor and the baseband unit from one vendor. So, and we can, other than the radio unit and antenna, this baseband unit, so we can deploy in any commercially available hardware, any HP
This
or Dell.
is similar to ISO OSI 7 layers. No? It's going to layer concept.
Yes, yes, yeah. So likewise, now that everything is comes into a open and virtualized kind of pattern, so there are also many opportunities people to do and uh, come up with their own solutions and take into the market. So with this, those large operators, multinational operators like Huawei, ZTE, those are being challenged nowadays. So we have seen many deployment with Open RAN, for example, like Rakuten Symphony in Japan. So they completely run on these open interfaces. So they don't rely on any vendor. So they have multi-vendor environment completely virtualized. And another vendor in US, it's called Dish Network. They also use this kind of open interfaces. So soon, all around the world, I believe that open and open RAN and open interfaces and multi-vendor environment will be adapted in a telco, and so that many software vendors can come up and do their solutions, and the competitions will be there. The other important factor comes with the 5G is the mobile edge computing. So we call MEC. In the mobile edge computing, what we are doing. So now we come up with much advanced applications like augmented reality, virtual reality, and metaverse. Those kind of applications we are come up with, but the problem is that we cannot host those things in the cloud. So we can do that, but there's a significant delay if you host those things in the cloud, and those applications consume much more bandwidth. So you need very high data rate and very high data throughput on those networks. If your metaverse or your whatever the application access in the cloud. As a solution for that, what 3GPP comes up with is that edge computing. Edge computing is that we deploy your data center at the edge of the network. That means maybe at the base station, right? So we can handle locally your data and increase the latency, increase the availability, and also reduce the international or the bandwidth, the transport network bandwidth, because everything we can now handle locally.
It reduces the latency,
Yeah, reduces the latency.
Mm.
So if you see the applications, one application is that content scaling. So like or video kind of streaming. So scaling can be done, resolution scaling can be done on the edge or other in the local connectivity. So if you don't want your data to go outside from your premises, you can have your local edge network at your office or your premises, and then all your data handled locally. Other one is the computing. So those the you can offload your computer requirement to the edge. So your device should not have that computing power. So you can offload it to the edge computing resources. Augmentation, those also the augmented reality, face recognition, those kind of content can be hosted in the edge servers, and edge content delivery. That means that you can store your content on the edge. So likewise, there are a lot of applications, and so when I go
So
to
this content delivery already, this technique is there, no? Edge delivery.
not the edge. Let's say, for example, like here in the mobile operators, we have YouTube and Facebook servers, but in that operator premises. But still, if you're accessing the YouTube, so you have to go to the, let's say if you are in the goal, you have to access the server in Colombo. But if you have
No,
the
it
edge
is now
computing,
the regional wise, they have their servers and the content is going to that edge. No?
yeah,
Rather
in the
than
mobile,
Colombo.
but in the mobile only the Colombo. I mean,
Colombo.
no distribution.
Right. But I know in the POTV, this IPTV,
yeah,
they are
POTV may
doing.
be used. Yeah, that is possible.
Yeah.
What we cannot do in that mobile is that in the mobile that the application has to be deployed after the core network.
Yes.
So the core network is in Colombo, then application has to be going off after the Colombo. Then what here we are doing is core network comes into the cell edge, site edge.
But we have the more than one base station controllers, no? So the control part is also distributed to some extent, no?
Yes, but yeah, that distributed, but the user data handling can do locally. Central, yeah.
Okay.
When you go to beyond 5G, so one notable discovery is this one, because I'm very interested in this project, this Starlink. So they are sending satellites. This is a low Earth orbit satellite. So these are closer to our Earth, and these can be covered entire world population with like maybe we need 1,000, 2,000, very high amount of satellite. But the outcome that we can get from that is that this is coming. So even in the 5G now, in the release 17, that the latest release of the 5G, Now we have specifications for now non-terrestrial network 5G. So that means your 5G phone can directly communicate with the low orbit satellite and start sending data. So there is a limit for terrestrial network as well. So as I said, when the frequency is higher, you cannot go much distance. But when the base station is on the space, so in the line of sight kind of deployment, right? So there's nothing in between you and the base station. So with the beamforming and those technologies, if the base station is on the space, or let's say not the space, but on there, so you will get much better experience. So now we are moving the 5G network also with non-terrestrial network kind of applications. So that is also there in the specifications as well. So in the 6G, we believe it's a baseline for 6G will be NTN, no non-terrestrial network. So we'll have both terrestrial network and non-terrestrial network, but we'll mostly deal with the terrestrial network, that the base stations, towers, and all the things. But time to time, or for some application, we will be connecting directly from your mobile to that satellite. So that is the upcoming thing that comes with the mobile technology, mobile world. So lastly, so in the 6G point of view, 6G discussions and 6G developments are going on. So in the 5G, we call it connected everything. So we now have the technology to connect everything. So we can connect cars, we can connect critical kind of applications.
Okay, before that, your previous one is the low orbit satellites. If there are about 2000 satellites, there will be a traffic in the orbit also. No? When you are going
Yes,
out of the orbit, there may be
yes,
some traffic control also in future.
yeah, so there are I can't remember, there's an organization that handles this. So they say
That is
that
the Intersat. Intersat is handling this. No?
some US entity, so they give like you have to in that kind of height and those things. For example, not only Starlink, there are multiple satellite constellations are already there. So they work in different heights or different
Orbits. Yeah.
orbits. Yeah.
Low orbit is about 300 kilometers, 200 to 300 kilometers. Normal
Yes.
satellite is geostationary satellite is 36,000 kilometers. I was a
Yes.
satellite communication engineer at the beginning.
Okay.
Yeah,
So
okay.
recently, actually, we are also trying to do this POC in Sri Lanka. So we that is for the IoT. So we are trying. We mostly this year we'll do that from satellite to IoT device from Sri Lanka with. So we already applied GRC for the approval.
Then even in a forest, you can connect to the internet, no? We have
Exactly.
something like that.
And the
Sea,
ships,
forest.
sea, sky, craft. Yeah, the last topic is that 6G. So as I told, 5G, now we know connecting everything that we know. In the 6G comes with the connected intelligence. So in that sense, what we are doing, so we bring cloud back to earth. So when we say cloud is far away. So cloud, when it comes in the mind, is cloud is on the sky, or cloud is far away. So we used to offload our computing requirement into the cloud. That means we send them some far distance, right? So that now that we have understood, that is not the always good thing, right? So we need that cloud with you. For example, now the concept is earth computing. So not the cloud computing, now earth computing. So that
Because
cloud comes back to earth.
most of critical applications are depending on the time delay, no latency. So we have to reduce the latency as much as possible. Yeah.
Exactly. The time delay as well as the capacity. So now that the applications need very high data rates. So if you want to transmit everything into the cloud, so you have to invest a lot on the transmission network, transport network. So, and those two factors are there. the latency and the transport bandwidth. So for that purpose, what we are doing, we bring back to cloud to Earth. In the 5G, 6G that we are talking, those intelligence, that means this describe this, that processing power, uh, that what when you, especially that applications like metaverse, you need tons of processing power, right? So everybody in a virtual space, and even it's everybody in that virtual space, in the virtual if you are experienced the metaverse, you know how much processing power you need to deploy a metaverse, actual metaverse, not some sort of a kind of a test run or something, but in the actual metaverse, you will need
Metaverse
very
means what are the spellings? Meta.
uh, META, VERS. So in that case, that you are living in the virtual world. So let's say if you are having that this lecture, so in the metaverse, then we can see each us, and what we are doing, and everything is displayed as we are physically in the same location. So that's what the concept is there. So in that case, we need much more data rate and lower latency. So such applications, but we cannot do in the cloud. So in this, the main concept in the 6G is bring back the cloud, and to do that, your network has to be that capability, right? So the 6G is what that purpose of, like here, that these are some things, that applications that we are discussing, that we cannot do in the 5G, and we'll be doing the 6G, like this uh, digital twin of your, and interactive telepresence. So likewise, that as I said, in the metaverse, the 3D hologram imaging, and so many new things are coming, and uh, we'll probably see this in 2030. So we will be seeing first specification somewhere in 2027 or 2028, but that people hope that 6G will go live in 2030, and that is the update so far. And this is actual timeline that ITU given for 6G, and uh, so last decision, or last recommendation from the ITU, so when they gonna uh, decide which regulator, which 3GPP, or whatever the technology that we are going with, the 6G is recommended in 2030. So they will say, okay, we are going with the 3GPP 6G standard. So that decision will be taken on 2030. So before that also, we will have some glimpse of 6G. So we'll see, but we don't know exactly yet what 6G will look like. But that is sort of 6G. And actually, that's all from me. So if you have any questions, please.
Yeah, if you have a question, you can ask him. So you can unshare the presentation.
So there are the holographic technologies. I haven't seen an example for that.
Okay, we'll answer that one later. Anything related to this mobile communication?
Excuse me. So how does the Starlink differs from the already existing sat phones?
Yeah.
So Chavika,
already
can you come on video? Then you see.
Okay. Yeah. What is that already existing sat phones need? It's if you see that one, it's a very bulky device. It is it has its own capabilities. It doesn't like a mobile phone. It's very large, and it not always accessible. So sometimes you have to go out of your building and go to a open space to make a call. But with this technology, that low Earth orbit, it's like your day-to-day mobile call. That's the difference. And that one is very expensive because it goes very long distance, and it need much your power from your side as well. So when it goes down, so the phone battery also keep some time, because you don't need much power to transmit.
Okay, thank you.
So it's a very interesting lecture. You might, if you have really followed this one, you might have a lot of questions to ask from you.
Actually, how many base stations you currently have in the island?
In Sri Lanka, Sri Lanka, we don't have a policy on the base station. So different operators, they have their own deployments, and some places they share it, right? So if you see, I don't have exact numbers, but in general, so I work in the Mobitel, so I know how much they had. So they had around 2,000 island wide. So I think Dialog having more, and some of, let's say, for some small operators, they are sharing with the large operators. So they pay some amount and rent a space from that tower, and they set up their base stations there.
Okay, I thought that there are few base stations in Sri Lanka. So seems like there are over 2,000.
Yeah, it will be even more in the 5G comes. So the frequency is higher, the cell radius is then lower. So cell becomes small cell. So in the future, like it's like 10,000, 20,000, maybe even more. So if you can go to the goal phase, you can see each lamp post. There's a tower, base station, 5G base station. So that's how the 5Gs look like. So everywhere in the lamp post and everywhere you'll have 5G. Maybe in your home also you'll have one.
At initial stage, all operators have had their own base station. Later on, TRC given the decisions to direction to share them as much as possible. Otherwise, the number may be very much higher than this.
Yes. But so some countries, that they have the government policy that the government decide where the base station should locate, and then everybody has to share that.
Base station will be a one operator. They are looking after only the base station. Something like that can be there.
Yes.
The possibility is there.
And also one question about telco hardware. So actually, what kind of hardware you are actually using in-house other than that tel towers? And
sorry, I didn't get that question.
I mean, what kind of telco hardware you actually using? Are they like computers and all, or?
As I said, there's a two kind of things: radio access network and the core network. So in the core network, it is the intelligence part. So they are it's very, there's a high processing power. Servers are used when we are in the virtualization. So generic servers are the ones using. So there are, like for example, so one application maybe like 100 virtual CPUs are used, like kind of server setups are there, like 1,000, 1,000.
Adding to that one, the hardware is similar actually. Only thing is the software is different. Sometimes maybe the operating system may be different. So the same server, we are using something else, can be used for the mobile operation also. Is that correct?
Yes. Same server that you're using for your other IT applications can be used for the mobile applications as well.
So are you using a cloud as well, or it's not?
Yeah, cloud is a thing that's coming up. So we recently involved
in-house.
I mean the in-house cloud.
Yeah. Not for the customers. I am talking about the in-house. Do you use cloud as a technology too?
No, what do you mean by cloud?
I mean cloud servers in outside.
Yeah, normally it's a data center. You have a lot of servers are there. These things will be shared. So that's the concept of the cloud. So say the Mobitel can have their data center and can be
Yes,
used as
exactly.
their cloud.
Yeah.
Or they can use the SLT data center. So we even dialog data center. So is that correct?
Yes,
Chairman?
exactly.
Yeah.
Because now that only the software is there, so you can deploy it in any cloud.
Yeah.
So even you can deploy in the public cloud, let's say for the Amazon or Google cloud, you can deploy it there, but that is also a possibility. So that we have nowadays we see some operators. We saw recently a Singapore operator, so they want not even a one cloud, they want a multiple cloud. Let's say, for example, they Amazon, Google, and many other even unknown clouds. So they deploy on all those clouds, so that even the one cloud failure, their services are not affected. Likewise, they are thinking. So public cloud also a possibility.
Okay, thanks.
Okay, one question in the
How will 6GB what will differ from 5G between 6G?
Yeah, so far that they also not officially say that, as I said, that 5G, so they have given ITU, so 5G network should have these capabilities. 6G, so far we don't know exactly what is there, but currently what they're having, these are the applications and these are the use cases that we should do. So some of the things I discussed, but in my opinion, one thing is one thing is sure, that from 5G to 6G, so what we are generally doing is we are increasing the channel bandwidth. So now we have, for the 5G, we have channel frequency up to 100 gigahertz. So we cannot go beyond that, because then our cell size is like few centimeters, right? Because when the frequency is higher, the distance is lower. So the 6G definitely will have much more presence in the space, satellite business. And the other thing is that those kind of new computing and the that currently we don't discuss, or we don't talk about the computing or the cloud kind of things in the cellular networks, right? So it is provided by the different entity. But with the 6G, actually that service will be provided by the network itself. So then those applications can easily, smoothly run, other than the third parties.
yeah, all these things are coming according to the requirements.
Yes,
So that's why then the requirement is there, then the concept is coming from the ITU, then it should be developed by the researchers. So
Yes.
that is the normal cycle.
Yeah. So even now that Google, so in the Google Cloud, they have mobile operators, edge computing, that service is provided by the Google Cloud. So that means they have just not keeping their servers in their data centers. Now they are bringing back that to operators. So likewise in the 6G, we will able to see most of the computing power with the network itself.
Another thing is the constraint in the processing power. Still we are using the digital as a current for the 1 and 0. So then the heating problem is there in the processor. So now we came to the saturated level, I think. So how we can go beyond that? So that the solution may be the quantum computing, something like that. Then the very small chip can have a lot of processors. At that time, these things, so the 6G may be the completely different thing. Maybe even your mobile phone can be a server with very high power. So is that correct?
Yes, exactly.
Yeah. There are some questions in the chat. One question is in the recent with the power cut, we have faced many issues with the cellular connection. Is there any specific reason for it? Yes, it's even the power base station, you need the power to operate these things. So if there is no sufficient battery power for the outage, the service can be interrupted. And how the different cellular antennas connect with each other, which is located in separate location, so there is no antenna-wise connection is there. So when you see how it is working, you should be able to understand that one. And next question, are there any unique feature of mobile communication in Sri Lanka compared to other countries? You can see the chat, no? Jamika?
Yeah, I can see the chat.
Yeah. Last one, can you just answer it?
Yeah, any unique features of mobile communication in Sri Lanka? In what sense? I think Sri Lanka is following the 3GPP standards. What is currently the uniqueness in Sri Lanka is that we are not progressing. So that is a problem. So even in India, Maldives all have 5G commercial networks, and but in Sri Lanka we don't have. And the other thing is that I see that the ARPU, as I showed you, that average revenue per user is dropping. So that is not a good thing. So let's say the revenue has to be increased, same time that users experience has to also be increased. For example, if you are now using 100 gigabit per month, right? So let's say in the 2 years time, so you will be using 300 gigabit per month, but the same way that you will little bit increase your expenditure on the size of telecom site. So this is not happening in Sri Lanka. So Sri Lanka always the ARPU is dropping, and mobile operators are actually struggling to keep up with the expenses. So a lot of problems in Sri Lanka nowadays. So they have most of the operators are now on loss making. So it's a Sri Lankan unique problem.
Yeah, the reason is the technology is evolving very fast. Can we cope up with this in technology? Many applications are coming. Are these applications are coming in Sri Lanka? Second thing is all these things are investments. So the operator should get the return from that. They have already invested a lot of money. Are they getting the enough return for that? Then also again depend on the country's economy. If the people can afford these things. So it's a cyclic one actually. So until the country's economy come to a healthy situation, as well as the proper policies are coming from the country, then only these things are developing. Yeah, okay. Any other questions? Right. I think
will there be good electric cars in the future in Sri Lanka?
Yeah, it is beyond this subject. So it can be. So autonomous cars may be coming along with these things. Yeah. Okay.